Hey, 30-2s. In this lesson, we're going to look at sets and set notation. So this whole unit's called set theory. And what you're going to find is there's going to be a lot of vocabulary that I need you to know. So this first lesson is really just a lot of the basics, the brand new stuff that I need you to know for this entire unit. Okay, so I don't think it's overly difficult, this first lesson, but lots of info I need you to know. So what are we doing in set theory? So what we're going to learn how to do here is we're going to learn how to organize objects. And what we're going to call a collection of these objects is a set. And in math, to denote a set, we use these squiggly brackets, or what they're called braces. Each individual item in a set, we're going to call an element. Now, you've actually done set theory before. You've probably done it a lot in social class when you're describing different things like people's different political ideologies or what people are thinking and maybe where do their thoughts or beliefs overlap. So I'll show you what I mean. Let's not talk about social, let's talk about English for a second. So we're going to organize the English alphabet into the following sets. So vowels, so we're going to call it capital V, and there's that brace, which means the set, A, E, I, O, U, never Y in math. Then our consonants, well, everything else, right? So B, C, D, and I'm going to skip down to the end here, X, Y, Z. And all letters, I labeled it capital U. I'll talk about why I labeled all letters capital U for a second. Well, that's all of them right there. And again, I'm just going to skip down to the end like that. Okay, there's our three sets. So very, very basic way to break up the English alphabet. Okay, why did I call set U, all letters set U? Well, it's all letters, isn't it? It's all vowels and all consonants. In math and set theory, we call that the universal set because it includes all possible elements. What can be said about the elements in set C in relation to those in set U? Well, consonants, I want you to notice, is that consonants are completely contained within the universe, right? They're completely contained within. So what we call that is something special. Okay, I'll tell you that in a second. What can be said about the elements in set V in relation to those in set U? Same thing. All of the vowels are completely contained within. So they're completely within is what I'm going to write here. So these are very specific examples. When all elements in one set are included in another set, we call this a subset of the other set. And we use the symbol. It looks like kind of like a sideways elongated U. So in our example above, we could say that C is a subset of U because all consonants are contained within the universe. And we could say all vowels are contained within the universe. So there's one big vocabulary. I need you to know subset and the associated symbol. What can be said about all the elements in set C and set V? Are there any elements in both of these? Well, no, they're consonants and vowels, so they have no overlap. They don't have anything in common. Nothing in common is another way to say that. Right? I'm either a consonant or a vowel. I'm not both. So this is a specific type of case. When none of the elements in one set are included in the other, we say that these sets are disjoint, meaning they're completely separate from each other. If we wrote out the number of elements in this set, we would have what's known as the empty set because they have nothing in common. The symbol that we use for empty set in 30-2 is just this. It's a set with nothing in it. The other symbol that we like to use is this, with a 0 with a cross through it. Okay, so two symbols that mean the same things. Write out all of the elements that are not in set C. Okay, well, if I'm not in set C, that means if I'm not a consonant, I'm a vowel, right? That's A, E, I, O, U. The elements of this set are called the complement of set C. And not the compliment like, geez, you're pretty. This means something different. It means what I'm not looking for, not. And how we denote that, the symbol, is I'm going to say, I don't want C. So I'm going to write C prime. That little tick mark right there is called a prime. So that means not C. I don't want any elements in C. So again, more vocabulary, more notation. What would happen if we added the elements in C and not C together? Well, just think about that for a second. C is our consonants, not C is our vowels. So if we put those all together, we're going to end up with all the letters in the alphabet, right? We'll get all letters. Whenever we add a set and its complement, what did we really just get here? We just got the universal set. Okay, so whenever we add a set and its complement, we have to have everything in the universe. So we get the universal set. Now, how many elements are there in set V? Well, A, E, I, O, U, so there's 5. So the answer is simply 5. But if you're happening to look at the textbook, when they ask this question, they're going to write the notation like this, N brackets V. Okay, it means the same thing. It means how many elements are in the set. It's completely correct notation. I just need you to know that we actually aren't supposed to use it in 30-2. So if you see that looking at a different resource, that's all it means. Now, an easy way to organize our sets is to draw a pretty picture. And we draw something called a Venn diagram, which I'm sure you've seen before. So first thing we do is we put a box around our sets because that's the universe. And out here, we're going to label capital U for the universe. And then what you're going to do is you're going to draw me, I guess they really don't have to be circles, but we always draw them as circles, our sets. So we've got the consonants and the vowels like that. But I kind of screwed up there because I want you to think for a second, what I should be thinking, not you, is the consonants and the vowels actually don't overlap. So again, they are disjoint. And a real easy way then to start talking about the information you have here is I'm going to write C equals 21 because there's 21 consonants. V equals 5, there's 5 vowels. The universe is 26, right? And then I could start, oops, not A, come on. I can start writing my elements in here if I wanted, like that. Okay, so a Venn diagram, again, is an easy way for us to organize our sets. There we go. There's pretty much all of our terminology for the entire unit. The other thing that's going to come up is some definitions, such as these two. Consider prime and composite numbers. Okay, I need you to know what these mean. So if I was looking at the set of prime numbers, so I'll call it capital P, I need you to know your first prime number is 2. Right? Remember, a prime number is divisible by 1 and itself. A composite number has multiple factors. So this would be, I missed 9 there. I'll just go out of order. Clearly needed another coffee today when I was doing this. So there's my 2 sets. Well, how would I describe these things? Well, if I drew myself a pretty picture of all numbers in the world, there's composite, there's prime. I would describe these things as disjoint because they don't have anything in common. So I would call these disjoint. There we are. So I want you to memorize prime and composite. I can't stress that enough. Okay, last question, friends. So I give you the diagram here, and Johan here is describing his favorite foods, I guess, and he's given us the following sets. He's got P for produce, F for fruit, V for veggies, S for fruit you can eat without peeling, and just on the outside here, we kind of got mushrooms. He just doesn't like mushrooms at all, so he just put them out there. Let's answer some questions. The number of elements in V. Well, I just go and count peas, corn, carrots, potatoes, beans. So the answer to this is simply just equals 5. Again, if you're looking at maybe the textbook or another resource, they would write it like that. I don't need you to. I simply just need you to tell me, hey, that's 5. Okay, list any disjoint sets. Well, that means sets that don't have anything to do with each other. So looking at just these three here, F, V, and S, F and V don't have anything to do with each other. And S and V don't have anything to do with each other. So those are our disjoint sets. Okay, I'm not going to talk about mushrooms in that one. Is F prime, so not F, equal to V? Is not F equal to V? When you get these questions about knots, what I find is the easiest thing to do here is I'm going to say, look, here's F, right? It's right there. But I want not F. So not F is everything on the outside of it, like that. So everything in that shading there. So is not F equal to V? No, because of Johann's dislike for mushrooms or likes mushrooms, I don't know. So no, we're missing the mushrooms. List the elements in S prime. Okay, well, S prime or not S. Well, what's not S? Again, what I'm going to do is I'm just going to maybe go to hot pink here. Here's S, everything in this circle. So not S would be everything in the shaded. So I would list out all of those elements. Now, last thing I want to talk about here is I notice looking at set F and set S here, I notice that S is completely contained in F. So if I was to describe that, I would say that S is a subset of F because S is completely contained in F. So there it is, friends. There is all the notation I need you to know for the entire unit and some very, very basics as to how set theory works.